There's plenty of research out there where you're looking at, did my algorithm run faster? Or did I get a better answer this time? And it's an abstract answer. It's an answer that appears on the monitor. Here, the answers appear physically right in front of you. Did the robot do what it was supposed to?
That's basically the lab for robotics and sensor networks. And that's just always been really interesting for me, including, artificial intelligence and, being able to not only take what my colleagues are working on with, simulations and stuff, but actually being able to implement it on the little robots and actually see it work. I really like that.
What we're looking at now is the idea that we can use sensor networks to predict traffic patterns as they change on the fly and perhaps adapt to changing events or changing situations to maximize those things that people want maximized, like how long does it take me to get to the store? Can I take a path that will hit more green lights and therefore get me to the store with higher miles per gallon? Or we can just take the memory from the GPS unit and from the accelerometer and write it in.
In terms of my research here with Dr. Smith and Dr. Crowley, they've always been right there every step of the way, but they've been very careful to make sure that, we're doing, a fair share of the work so we learn in the process as well. In conjunction with the accelerometer data.
One of the things that attracted me here was the quality of the undergraduates and the ability to involve undergraduate students in research.
I hope to have a conference published paper by the time I graduate. That is basically like a key to grad schools. Not very many undergrad schools at all offer any type of research for undergrad students. So the ability to actually have a program here where I can kind of jump ahead of the rest of the pack, but still have a good time and do something that I like is a really big thing here.